Welcome back to this part of the lecture. Now, in this part, we'll continue what we talked about. Now, since we talked about the charge and we defined like the negative and positive charge and how the negative can be created and the positive can be created from the atomic type of structure, we said like the negative charge will be created by transfer and gain electrons. The positive charge can be created by losing electrons. And we know that the positive charge it's concentrated at the nucleus, and it's not an option to move a proton from the nucleus. And that's why we say like the electrons are the particles that has the ability to move from one atom to another atom. Now, one of the questions that we need to ask, how do we know that if the object is charged or not? In order to find this, we have something we call the electroscope. The electroscope, it's a device, a very simple device. We can use it to see like if we have an object, a charged object or not. And how this electroscope is working, it's very simple. It's formed by a metal, and this metal, by the way, it's a conductor, as we will see later on. The conductors are the type of material that we can use it as sensor to the electricity. So it's formed by a metal, and this metal, by the way, it's formed by a material that has like a free electron. So if you think about this metal, we can see like it's formed by atoms, and these atoms are kind of rigid, not moving, or it's oscillating, but we can think about like as it's a solid situation. So the atoms are fixed, but there we have what we call like free electrons. The electrons of this material, it's not strongly connected to the atom, and these electrons can jump from one atom to another atom. And that's why in the room temperature we can see that these electrons are free electrons, and they are moving around like the air molecules inside the room. We know that there is air, and the air molecules are moving around. So you can think about the electrons in the conductor or in the metal as the air molecules are moving around inside the room. Now, because of this, because of these free electrons, any kind of particle or object that has a charge, for example, let's assume that this is like a positive charge. Now, since we have like a positive charge, we know like the atoms, these electrons will interact with the charge. Negative with negative repel each other. Positive with positive also repel each other. Negative with positive interact with each other. Now, because of these type of interaction, as we can see here, because of these type of interaction, we will start to see some changes will happen because of that. Now, if I, for example, have like an object with a positive charge. Now, this positive charge, it's formed on that object. Now, these free electrons, now we will see that positive charge is getting close. And because of that, what's going to happen? We will think about this, attractive. Negative with positive attract each other. And because of this attractive, and these free electrons are free, they are able to move. That's why, since they are able to move, they will try to what? Shift it. And they will try to get close to this object. And if we apply this type of concept in the electroscope, so what the electroscope is all about, we have a metal, as we say, like metal means what? Means like it's a conductor, means like there's free electrons, means that if we have like an object with a excess charge, could be positive, could be negative, it doesn't make any difference. What's going to happen? The electrons on this electroscope will start to what? Interact with this external object, the charge of the external object. And that's why they will start to shift. This shifting here, it's will make the difference. Now, how is that? This electroscope actually is formed by what? By as you can see here, it's formed by a metal, and this metal actually has two arms. One fixed arm, the green one, as you can see here, this green one is a fixed, and the yellow one is kind of movable. Now they are connected here, as you can see, with this pivot, as you can see. Now in the normal way, these two are kind of what? Straight up without any problem. Now if I bring, for example, here a positive charge, what's going to happen? Negative charge of this metal will try to move up. As you can see here, they will start to concentrate at the top here, and when the electrons are moving up, shifting up, that will create what here? A positive charge in the lower part. So the negative charge will not jump, actually will not go from this one to here. No, actually will just be shifted, and because of this shifting, the negative charge will move up, and when they move up, they will leave behind what? A positive charge. And now we look at this one here. This arm has a positive charge, and this also arm has a positive charge, and because of the reason we said like here, positive with positive will repel each other, what's going to happen here? This arm will start to what? Feel a repulsive force, and that's why it will start to what? Get deflected. And here is the idea. When we see like this arm is deflected, we can easily say that this object is what? Is charged. If this object is not charged, for example here, there is no charge here, the whole metal here will not feel any type of interaction, and that's why there will be no redistribution of the charge, and that's why the arm will stay in the same location. But if this one is charged with a positive, the negative charge will start to concentrate at the top, and that's why they will leave behind what? A positive charge. Now what about, someone will ask, okay, but that's the case if we have a positive charge. What about like if we have a negative charge? I bring here negative. What's going to happen here? Is this electroscope will show me any type of reaction? Actually yes. This negative charge with the free electrons that they already like they are on that metal, what's going to happen? They will start to feel what? A repulsive force. We know like negative with negative repel each other. So what's going to happen? These negative charge will move down. So in this case, what do we have here? Negative, 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 and that will create here what? A positive charge. And again, negative with negative, the fixed arm and the moving arm will start to repel each other, and again we'll start to see the deflection, and that's how we can see that this electroscope will be the device that we will use in order to test if the object is charged or not. Now, as I said here, electrons are transferred from the, now here is the thing here. Now let's try to see here. If I want to show you a video that will explain what's happening here. Now let's see here. What do we have here? We have, look at this, we have a plastic rod with a viewer. Now when I rub this plastic with a viewer, as you can see here, the charge will start to transform, and because of that, this plastic rod will start to have what? A charge. And if I make this one close, as you can see, to this small piece of cotton, as you can see here, which is hanging through this string, this one will start to feel what? An attractive force. If I do the same thing here but for a different material, as you can see here, I have like a glass rod. Now instead of viewer, I have what here? Silk. Now if we do this one here, look at this one, this type of rubbing will also create a charge on the glass, and because of this charge, this glass will attract the piece, the small piece that is hanging. Now if I apply this one, by the way, to different type of object, as you can see here, now look at this, the same viewer with the plastic rod. Now we have here what? Small pieces of paper. If you can see this one, if you can observe it again, as you can see here, if you look at it, focus, you will see like these piece of papers, they are kind of attracted to this one. The same thing will happen to the glass and the silk, glass rod with the silk with the small pieces of paper. We will see like this one will start also to show me the same type of here. Okay, it looks like this video finished before. Okay, now let's go back to our explanation. Electrons are transferred from the viewer onto the plastic rod, and this rod now carries like a negative charge. Electrons are transferred from the glass rod into the silk, and that's why the glass actually now the glass rod now is carrying what? A positive charge. Now look at this one. The plastic rod is carrying what? Negative. How this will happen? By the electrons moving from the viewer to the plastic. In the case of the glass and the silk, it's the opposite way. The electrons transfer from the glass to the silk, and that's why the glass will have what? A positive charge, while the plastic will have what? A negative charge. Now, we talked about this in the previous slide. Positive with positive repel each other. Negative with negative repel each other. Positive with negative will attract each other, which is somehow different little bit from the gravitational force. The gravitational force is always attractive force. But in the electrostatic force, it's a little bit different. We could have like a repulsive force, and we could have an attractive force. Repulsive if the charges are similar. Attractive if the charge are opposite to each other. Now the question is, why when we have this video, when I have this piece, as you can see here, when I have the plastic rod which is charged, as we said here, with a negative charge, when I try to approach it to a neutral. Now, by the way, this piece of cotton, the one that you can see here, it's a neutral. Why this a neutral object is attracted to the charged object? Why? What's the reason behind this? The reason behind this one, by the way, as we can see here, and that's what we call the static cling here. What is the force between electrically charged object with a neutral object? As we did in the video here, the plastic rod has a negative charge, while the cotton here is a neutral. But when we approach this one, what's happening here? What's happening like an attractive force, and we could see that in the video. Why we have an attractive force? Because of what we call the polarization. This negative charge that is coming from this plastic rod, will affect the atomic structure of this. How this will happen? By shifting the negative charge in the opposite way, in such a way that in a neutral way, like we know like the atoms are formed by neutral. The negative charge in this case will be shifted to the other side, and that will create here what? A positive charge. If we have a positive charge and we have a neutral, the negative charge will be attracted, and that will leave behind positive charge. And that's why we have what we call here attractive force. So what we learn from this, we learn that charged object, when it's interacting with the neutral object, what kind of interaction we will expect to have? An attractive force. Why this attractive force? Is because of what we call the polarization. What's the polarization? The material of the neutral object will kind of split the negative and the positive in opposite direction, in such a way that the opposite charge will be attracted to the source that's approaching. So if this is negative, the positive charge actually will be the one that is on that side. Why? Because the negative charge will be what? Repelled, and it will be shifted away, and that's why we will end up with what here? Let me make it clear here. That will create here positive in that side and negative on the other side. That's what we call the polarization, and that's why we expect to have what? An attractive force. The same thing will happen if we have positive charge. Now, since I'm talking about charge as the source of the electric interaction, now it's very important for us to define this quantity. And if I want to define the quantity here, I need to define a unit. The unit of the charge is what we call is coulomb. So, and we'll use the letter C to describe it. So C is the unit that we'll use it for the coulomb. And why is that? Because the physicist who defined this quantity, his last name actually is Coulomb. And because of that, we will use his last name as a way to describe this unit. Now, how large is this quantity here? The coulomb is defined in terms of the SI unit as for the electric current. Actually, we will see that if you look at the table that we define in Physics 1, in the first chapter, what are the SI units? The SI units actually for the electricity, we use the ampere, and we will see that, we'll talk about that later on. But we can define the coulomb using the SI unit as ampere second. And ampere is the unit that we use to define the current, and the second is the time. Now, so that's why the coulomb is defined as 1 ampere second, and we'll talk about that, about the current later on. But the question is, what is the, or like how large is this quantity here? So the question here, what's this unit here? And what can we learn about the charge unit? The charge is a quantized type of quantity. What's the meaning of that? It means like it's always coming with a multiple of the minimum charge that we can observe in this universe. And this minimum charge, by the way, will be what? The charge of the electron. So the minimum charge can we observe is the charge of the electron. And any charge can we create will be a multiple of that charge. And that's why we call it like here what? A quantized. So you will not ever find like an object like with 5 of the electron, the charge of the electron, or a fraction of the charge of the electron. It always should be what? An integer number, a multiple of the electron charge. And so the minimum charge is the charge of the electron. Now, what is the magnitude of the electron charge? The magnitude of the electron charge, as we can see here, is 1.6 times 10 to the power minus 19 coulomb. 1.6 times 10 to the power minus 19 coulomb. We don't have to memorize this, but I'm sure at some point during the semester this will be in your mind, because we will use it a lot. Now that's what we call the magnitude of the charge of the electron. It's 1.6 times 10 to the power minus 19 coulomb. Now, we talked about the fact that the positive charge, negative charge in the atom, the proton, which has the same amount of the electron but opposite sign. So the charge of the electron, QE, is equal to what? Minus E. The charge of the proton, Q, will be what? Positive E. So I will use the letter Q as a way to describe the charge. So how can we well define the charge? The charge will be what? Defined as Q. So we'll use the letter Q. Now the minimum charge we will have is the charge of the electron, and it's equal minus this magnitude, 1.6 times 10 to the power minus 19 coulomb. The charge of the proton has the same magnitude, which is 1.6 times 10 to the power minus 19, but with a positive charge. Now, how can we describe the charge in general? As the letter Q. We could have it like a small letter or capital letter. So whenever you see like Q here, it means like we are dealing with charge. And this charge should be what? A multiple of electron. As I said, like in this case, electron is the elementary particle with a charge minus E. The proton has the same magnitude but with a positive charge. Now, the coulomb of the charge, as you can see here, the coulomb is a very large unit. If you see that the charge of the electron, which is minus E, which is minus 1.6 times to the power minus 19 coulomb, Now the question is how many electrons I need in order to create one column. It's very straightforward. Divide by one column over 1.6 times 10 to the power minus 19. That will give me like how many electrons I need in order to create what? One electron. Keep in mind that Q in general should equal N times E. N is what? Is integer. N integer means what? Like any charge will be created. It will be always a multiple of the electron charge. And there is no way that I can split the electron. Have like, for example, has like half electron. Or fraction of the electron. No. It's always an integer number. And that's why we say that the charge is a quantized quantity. It's always a multiple of the electron charge. Now that's why, because the column is a very large quantity, and this large quantity here, it's not easy to create. So in many cases, when we talk about point charges, we will deal with scale of the charge as microcoulomb, nanocoulomb, or picocoulomb. Micro is 10 to the power minus 6, nano is 10 to the power minus 9, and pico is 10 to the power minus 12. So this is, you don't have to memorize this one, but we have to keep that in mind. Okay, let's stop at this point here. In the next part, we'll talk about more about the charge, and we'll also talk about more about the property of a material.